Hey, how's it going, everybody? Mr. Farrell here. I just wanted to give a quick demo or help video on a couple of the acceleration videos or equations we've been using in class. So we've got our three acceleration equations listed over here. These last two are in a special category called the kinematic equations, okay? Now, we haven't talked much about the kinematic equations in general. In fact, we're only covering these two in our course. There are a number of them, about six of them, 5 or 6 of them. Here we have our standard acceleration equation, all right? And this is telling us that acceleration is equal to your change in velocity, right? Your second velocity, your last velocity minus your first velocity, that'll give you the change. So it's your change in velocity divided by your change in time, okay? Now, if you remember, that's very similar to the equation for velocity. The equation for velocity, though, is displacement over time. So acceleration is velocity over time, but velocity is displacement over time. So very similar equations. One more time, just reiterating, velocity is your change in position over time. Acceleration is your change in velocity over time. So again, very similar equations. Now, the first kinematic equation that we see is actually very similar to this acceleration equation. You've got the V2, you've got the V1, the acceleration A, and the change in time, delta T. So it's got all the same pieces as this first equation. The only difference is this kinematic equation is solving for your final velocity. Okay, it's solving for your V2. And V1 here is just your initial velocity. I know that some people get confused when they see these numbers and they think that means we square the velocity. Remember, if you see a number below the symbol, that is called a subscript. It is not an exponent. A subscript is just telling you, I've got two things, they're both velocities, but they're different. And the way that I show you that they're both velocities, but they're different, is I put a subscript next to them to say, hey, this is a velocity, but it's velocity 1, and then this is a velocity, but it's velocity 2. These are not being squared, these are not exponents. They're just telling you the difference between the two velocities that we have, okay? And then our last equation, another kinematic equation, this is helping us find the displacement, which is delta x. Now, just like our other equations, it has V1, it's got delta t, it's got acceleration. This delta t here, now this is where we see an exponent, right? This 2 is not written below the symbol of delta t. It's not written below it. So we know it's a exponent because it's written above our symbol, our variable, delta t, okay? So the only thing different about this equation is the addition of delta x into the equation, all right? So now we're gonna do a couple practice problems. All the practice problems I'm covering today are from some of the class practice problems that I did and covered earlier, like a week or two ago. But this is just so that we're familiar with it or growing in our familiarity with these problems and how to use these equations, okay? So, give me 1 second. All right, so first one says, a car is moving with an initial velocity of 10 meters per second. After driving for 10 seconds, the car is traveling at 20 meters per second. What is the car's acceleration? Okay, so the first equation we're working with is going to be this equation, okay? If you want to know how to use the other equations, you can skip ahead in the video, all right? But we're going to use this equation first. All right, so for problem 1, again, we want to use our ICE method, so I-C-E-E. Let me draw my lines in here. Okay, so it said, again, what we want to do is just write our knowns and unknowns, right? We just want to write the measurements, the numbers that they're telling us in the problem. So it says the initial velocity is 10 meters per second. After driving for 10 seconds, the car is moving 20 meters per second. What is the car's acceleration? Okay, so we literally just wrote down every measurement they gave us, and then we wrote down a question mark because they do ask us a question. Now we're going to have to figure out what each of these measurements is, what symbol are they in this equation. But first we just want to write them all down, write down our question, okay? So now we're going to go ahead and categorize these. So it says 10 meters per second is the initial velocity. Initial velocity is just the same as saying your starting velocity. So we're going to label that V1, okay? 10 seconds, because it's seconds, we know this is time, okay? 20 meters per second, that tells us the ending velocity of the car. So that is V2, the final velocity or ending velocity. And the question asks us, what is the car's acceleration? Now I know a number of folks who get confused on this part of the ICE method, or they don't do it and skip over it. Do this part. It's very easy because in the problems, it's telling you initial velocity is 10 meters per second. Time is this. Final velocity is this. So if you read the problem closely, you'll know what symbol each of these are. So just pay attention to that. Okay? So now we've got to choose our equation. And this is where things get a little interesting. Okay? Let me go ahead and draw a line just to separate these two sides. Okay? Now the reason things get interesting here is because we actually have two equations that have all these symbols in them. Okay? The way we choose our equation is just which equation has all the symbols we're looking for. We're looking for V1, delta T, V2, and A. Now this equation and this first kinematic equation both have V1, V2, A, and delta T. Okay? This third equation here does not have V2, so we can't use it, right? Because we're looking for V2. Also, this third equation has delta X. We don't have delta X over here, so we can't use that equation anyway. Now, between these first two equations, which one are we going to use? Okay? In order to figure that out, since they both have all the same variables, all the same symbols, we just choose the equation that's solving for what we're looking for. Now, we're looking for A, acceleration. So this second equation is set up to solve for velocity, V2, the final velocity. This first equation is set up to solve for A, acceleration. So this is the equation we're going to use. So I'm going to go ahead and plug it in. Acceleration equals V2 minus V1 over delta T. And I'm going to come down here to my evaluate step and just plug in all my numbers. So I got 20 meters per second minus 10 meters per second, all divided by 10 seconds. Okay? Now I'm just going to solve. So 20 minus 10 is 10. I keep my units, meters per second. And then 10 seconds over here, just carrying that over. And so now we have 10 divided by 10, which is going to be 1. And I still need my units. Now, I already know that my units of acceleration are meters per second squared, or displacement over time squared. Here we can also see it because we've got meters, seconds, over seconds. So we've got these 2 seconds. We know we're going to square that. Meters per second squared. All right? So that would be my answer for this equation. Again, just make sure to take note of how we labeled all of our symbols according to what they told us in the problem. One of the issues I see some students do is sometimes the starting velocity is actually lower than the ending velocity. For example, if a car was driving and they saw an accident and they started to slow down, that means the car's initial velocity might be 50 meters per second, but its final velocity could be 20 meters per second because it slowed down. That means our acceleration would end up being negative because we would have 20 meters per second as our final velocity minus 50 meters per second, which is our initial velocity. So if you get a negative answer, that doesn't necessarily mean you're wrong. Just make sure to read the problem closely to make sure that your initial velocity, you're labeling that as V1. Whether it's a big number or a small number, doesn't matter. If the problem tells you that's the initial velocity, label that as V1. And then whatever your final velocity is, label that as V2, okay? Nice, so we're gonna go ahead and erase all this and move on to another practice problem that helps us use another equation. All right, again, when you're doing these problems in class, you do not have to use the ICE method, but it is so helpful, I highly recommend it, all right? And if you don't normally use the ICE method, still learn how to use it so that if you run into a problem where you get stuck, then you can get unstuck. Okay, so the next equation we're going to be using is this equation here. Okay, and again, this equation uses all the same variables as the first equation, so it's very similar in how we solve the problem. Okay, but let's go ahead and plug in some of these numbers. So we say in one of these problems, a dodgeball has an initial velocity of 18 meters per second. Okay, the dodgeball accelerates at negative 2.4 meters per second squared, right? And meters per second squared are the units of acceleration. It says it accelerates at that rate for 1.9 seconds. And the question is, what is the final velocity of the dodgeball? Okay. Another thing, a lot of people tend to forget or ignore putting the question mark. Always put your question mark because you need to know what category that falls into. What symbol are you looking for? What symbol is the question you're asking about? Okay. So always put that there. Okay, so it says we already listed all the measurements and numbers they gave us and our question. Now we're going to go ahead and categorize them and write their symbols. So it says a dodgeball has an initial velocity, okay? Initial velocity is the starting velocity, or V1, okay? Then it says it accelerates at negative 2.4 meters per second squared. So it told us that it accelerates, so we know that's acceleration. Now this acceleration is negative, which means this dodgeball will be slowing down, okay? So just make sure to take note of that. Now it says it's accelerated at that rate for 1.9 seconds. Again, because this is seconds, we know this is time, so that's our delta t. And the question asks us, what is its final velocity? All right, final velocity or the ending velocity is V2. Now again, we have all these symbols, all these variables, and we find that they are in equation 1 and equation 2, okay? V2 is not in equation 3. Equation 3 also has delta x, which we don't have any delta x, so we know we're not using this equation, all right? But the way we choose between equation 1 and equation 2 is, since they both have the same symbols, the same variables, you just choose the equation that has that is solving for what you're looking for. So we are looking for velocity 2, and this equation, the second equation, is solving for velocity 2. So that's what we're going to use. So we're going to put V2 equals V1 plus A delta T. Okay? Now we're going to just go ahead and plug in all of our measurements. So V1 is 18 meters per second. Acceleration was negative 2.4 meters per second squared. And the time was 1.9 seconds. Okay, so now we're going to make sure to do our proper order of operations. Okay, so we're not going to do addition first, right? We have to do multiplication, any multiplication before we do addition. So we're going to put 18 meters per second, just rewrite that, plus, and now we're going to do this multiplication here, which is negative 2.4 let me go ahead and write that. Negative 2.4 times 1.9. All right, so that's going to give us negative 0.456. Negative 4.56. All right, now we also have to write the correct units here. All right, and we've got meters over seconds squared being multiplied by seconds. Now, this seconds is in the numerator of its number. This seconds is in the denominator. So we know the seconds will cancel out here. But here we have s squared. That means we have two s's in this denominator. Here we only have one s in the numerator. So we're going to cross out the 2 because we're going to cross out one of these s's with this s. So we're only left with one s, okay? One of these s's crossed out one of these s's, so now we only have one s left instead of 2 of them. All right, which is why that was squared. So we're just going to write meters per second. All right, now we can go ahead and do our addition, okay? So 18 meters per second plus a negative 4.56 meters per second. That is going to equal 13.44, a positive 13.44 meters per second. Okay. Now, one thing I want to note about this, just previously in the problem we did, I was telling you, sometimes your final velocity is actually slower than your initial velocity. You start off sometimes faster than you finish, okay? And here we see that our final velocity is 13.44. Our starting velocity was 18, okay? And that is just telling us that our object slowed down, which if we look at our acceleration, it was a negative acceleration. So we know that our object was slowing down while it was moving, okay? So don't be afraid of getting negative numbers. Just make sure that you've ordered things correctly. You've put them and labeled them as the correct symbols, okay? So I'm gonna go ahead and erase this and we'll do our last acceleration problem. Okay. So for our last problem, we're working with our final equation, equation 3. All right. So for this problem, the problem says the initial velocity of a track runner is 0 meters per second. Okay. They accelerate at a rate of 3 meters per second squared. Over 6 seconds, okay? So that's another number, measurement we see. How far did the track runner travel, okay? So again, notice, there's nothing special that I'm doing in our first step. I'm just reading the problem, and anytime they give me a number, I'm writing that a number, a measurement. I'm writing that number with its units, just writing it down, okay? Because all of those measurements are gonna have to be categorized. All right, over here with this question mark, again, I can't stress it enough. Always write your question mark. If you cannot categorize your question and you don't know what symbol you're looking for, then how do you expect to solve the problem? You have to know what you're looking for. So always write your question mark so you practice figuring out what you're looking for, all right? Now let's go ahead and categorize these. So the problem told us the initial velocity of the track runner, all right, is 0 meters per second. So that is V1, that is the initial velocity. Then it says the track runner accelerates at a rate of 3 meters per second squared. So we're gonna put A down for acceleration. And it tells us this time, okay, because we know it's 6 seconds, that is delta t, that's time. And then the problem says how far did the track runner travel. Now we're looking for displacement or distance. How far did they go? Whenever we're talking about displacement, that's delta x, okay? So now we have all of our measurements and our question connected to a symbol. They're all labeled. So we have to choose which equation to use. Now we have V1A delta t and delta x. Because we have delta x, when we look at this first equation does not have a delta x, so we can't use it. This second equation does not have a delta x, so we can't use it. The third equation has delta x, so that looks good. It's got our V1, it's got our delta t, and it's got our a. So this equation works great, all right? So we are good to go because we got our equation chosen. So let's go ahead and rewrite it. Delta x equals V1 delta t plus 1/2 a delta t squared. Okay? So now let's go ahead and plug in our measurements so we can solve this problem. So V1, we said was 0 meters per second. Delta t is 6 seconds. Plus 1/2 times the acceleration, which is 3 meters per second squared, times the time, which is 6 seconds, and the time gets squared, 6 seconds squared. All right, so now we're really gonna have to remember to use order of operations correctly because we have multiplication, we've got addition, and we've got an exponent. If you do that in the wrong order, you can get the wrong answer. So let's make sure we use our proper order of operations. So our order of operations is please excuse my dear Aunt Sally. So P for please, that's for parentheses. Inside of the parentheses, we only have single measurements, we only have single numbers. So we don't have any operation inside of a parentheses that we have to do. So we can move on to please excuse. Excuse, E stands for exponents, okay? So this exponent right here is the only exponent in the problem, so we're gonna have to do that first. So let me just rewrite everything until I get to that point. 0 meters per second times 6 seconds plus 1/2, make that clearer, plus 1/2 times 3 meters per second squared. All right, now when we do this exponent, we want to square everything in the parentheses. So that means 6 squared is 36. And then we also do s squared, which is just going to be s squared. But you have to square everything, in the parentheses. So the 6 gets squared and the s gets squared. Okay? So now we can move on to the next step. So we did please excuse my dear, okay? So M stands for multiplication, D is for division. We don't have any division between numbers here, all right? Everything is written as multiplication. So we can go ahead and multiply all of this stuff. Let me show you the marker. We can multiply all of this stuff and multiply all of this stuff. There's still addition separating these two, so we're not going to add anything yet. We're just going to multiply this stuff separately and then multiply that stuff separately. Okay? So let's do 0 times 6. Anything times 0 is 0. Okay? Now we've got to deal with these units. All right? So we've got seconds in the numerator over here, and then seconds in the denominator over here. So these cancel out. We've got seconds in the numerator, seconds in the denominator. So we are left with M for meters. Okay, so 0 meters plus, and now we're going to go ahead and multiply these straight across. All right, this was seconds squared. So we've got 1/2 times 3 times 36. 1/2 times 3 is going to be 1.5. And then 1.5 times 36 is going to be 54. Okay. Now let's look at our units again. Now this is second squared in the numerator. This is second squared in the denominator. So the whole thing gets canceled out this time. So second squared cancels out with second squared. We are also left with meters. Okay? So now we have 0 meters plus 54 meters. So 0 plus 54 is going to be 54. All right, we've got our unit of meters. So this is telling us that this person traveled 54 meters during this time. All right. Awesome. So that's all we're going over for this video for acceleration and working with these different acceleration equations. Thanks for joining us and have a good one.